Welcome everyone! This is the second of 3 lecture videos for this week, which are meant to reinforce and clarify important concepts. This one is about cross-sectional studies. Cross-sectional studies are also called surveys, or prevalence studies, or polls. Cross-sectional studies are conducted by collecting data from each study participant at a single point in time, only once. This is opposed to following people over time and asking them questions at various intervals, like longitudinal studies. Cross-sectional studies can be descriptive or analytic, depending on the goal of the study. Let's talk about descriptive cross-sectional studies first. The goal of these are to perform descriptive epidemiology, that is, to describe the distribution of some health issue by person, place, and time. An example of a descriptive cross-sectional study is the National Health Interview Survey, NHIS, which you may have seen last week if you visited the CDC Chronic Surveillance System website. This is one of the many surveillance system studies conducted by the CDC where they randomly select people from across the country to participate each year. Each person provides data just once. For the NHIS, participants take a survey, they are interviewed, and some biological measurements are taken. Again, the CDC conducts this study each year, but different respondents are chosen each time. This means each respondent provides data at only one point in time. Here is an example of a result from the NHIS descriptive cross-sectional study, the prevalence of adult binge drinking by state. The Youth Risk Behavior Surveillance System, or YRBS, is another example of a descriptive cross-sectional study that serves as another CDC surveillance system. High school students across the country are randomly selected each year, and participants complete questionnaires about health behaviors. Like the NHIS, the YRBS is conducted each year and different respondents are chosen each time, so each respondent provides data at only one point in time. This graph shows YRBS results for trends in sexual risk behaviors over time. You may wonder, if each participant provides data only once, how is it possible to know trends over time? The reason is that although participants are always different, the survey questions are the same year after year. So the survey asks the same questions each year and then can plot a result for each year, and we can see trends over time. Now let's talk about analytic cross-sectional studies. Unlike descriptive cross-sectional studies, which have the goal of describing the distribution of health issues by person, place, and time, the goal of analytic studies is to investigate determinants by testing for associations between exposures and outcomes. So it's the goals that separate descriptive and analytic cross-sectional studies. What separates analytic cross-sectional studies from other analytic study designs is when exposure and outcome data are collected in relation to each other. Cross-sectional studies assess exposure and outcome data at the same time from each participant. For example, an analytic cross-sectional study to assess the association between living in a dangerous neighborhood and owning a gun. The exposure is living in a dangerous neighborhood and the outcome is owning a gun. The goal of this study would be to find out if there is an association between these two variables. Participants would be asked both of these questions at the same point in time and only once. A major limitation of analytic cross-sectional studies is temporality. Temporality means timing, and in the context of epidemiological studies, temporality refers to the issue of whether we can be sure that the exposure happened before the outcome. Being able to do so is necessary if we are going to say that the exposure is a risk factor for the outcome. For example, if a dangerous neighborhood is the exposure and owning a gun is the outcome, did living in a dangerous neighborhood lead someone to owning a gun? Or is it possible that someone owned a gun before they lived in an unsafe neighborhood? If the study finds an association between these two variables, the only conclusion we can draw is that living in a dangerous neighborhood is associated with gun ownership. We can't say that living in a dangerous neighborhood is a determinant of owning a gun, or vice versa, because we can't be sure which came first. Temporality is not a limitation if the exposure can't change or is historical. Exposures that can't change are things like blood type or sex at birth. Historical exposures are things like having your appendix out or growing up in a home where an adult smoked. For these types of exposures, a cross-sectional study can establish temporality. That is, we can be sure that the exposure came before the outcome. One major strength of cross-sectional studies in comparison to other study designs is that they are generally quicker and less expensive to conduct. since participants can be recruited from the general population and data are collected from each participant only once. This is opposed to other study designs that have to find a special type of participant to study whatever it is they want to study, or they have to follow participants over time and gather data at regular intervals, which is time-consuming and costly. The other major strength of cross-sectional studies is that if the participants were randomly sampled from the general population, the study results can be generalized back to them. This is called generalizability. In the last lecture, we started going through this flowchart of how to identify a study design, and we made it to distinguishing experimental versus observational studies. There are three major types of observational studies. Cross-sectional studies are one of them. The way we distinguish the different observational study designs has to do with when the exposure is measured in relation to the outcome. As we've discussed, if they are measured at the same point in time and only once, the study is cross-sectional. You may remember that cross-sectional studies are also called prevalence studies. This is because prevalence is the only measure of frequency that can be calculated from cross-sectional study data. The reason is that data are collected at only one point in time. Since there is no follow-up, we can't measure incidence, which is the proportion or rate of new cases that occur in a population at risk during a time period. If we wanted to measure incidence, we would start with people who did not have the outcome, in this case, who did not own a gun. Then we would need to follow people over time to see what proportion of people who lived in more versus less dangerous neighborhoods ended up acquiring a gun. A study like this, that measures incidence, could determine if living in a dangerous neighborhood was a risk factor for gun ownership. However, if the study is cross-sectional and we ask about both variables at a single point in time, the only measure of frequency we can calculate is prevalence, and the only conclusion we can draw is that the variables are associated or not. From week 2, we already know how to calculate prevalence for a cross-sectional study. The point here is that we calculate the prevalence of the outcome for the exposed group and unexposed group. The way we find out if there is a relationship between the exposure and outcome is to calculate a measure of association. The ones we can calculate for cross-sectional studies are prevalence difference and prevalence ratio. Prevalence difference is the prevalence of the outcome in the exposed group minus the prevalence of the outcome in the unexposed group. If the answer is a positive number, then you can interpret it as the number of cases attributable to the exposure, or the number of excess cases associated with the exposure, or the number of cases that would be prevented if the exposure were removed. If the calculated prevalence difference is negative, you can interpret it as the number of cases that are prevented by the exposure. If we go back to our example from week 2 of living near fast food and obesity, we calculate a prevalence difference of 0.13. We can then plug in the names of the variables from the study into the interpretation sentence and end up with 13 cases of obesity per 100 people are attributable to living near fast food restaurants, or living near fast food restaurants is associated with 13 excess cases of obesity per 100 people. Prevalence ratio is calculated by dividing prevalence of the outcome in the exposed group by the prevalence of the outcome in the unexposed group. Prevalence ratio is interpreted as the number of times higher or lower the outcome is in the exposed group relative to the unexposed group. This generic interpretation sentence works for positive and negative prevalence ratios. Remember, the baseline for a prevalence ratio is 1, so a positive prevalence ratio is above 1, and a negative prevalence ratio is below 1, so it's a decimal 0 point something, but would not have a minus sign in front of it. In our fast food example, the prevalence ratio is 1.65. We can plug in the variable names into the generic interpretation sentence, and our interpretation becomes, people who live near fast food had 1.65 times the prevalence of obesity compared to those who didn't live near fast food. We could also turn the prevalence ratio into a percentage and say that people who live near fast food had a 65% higher prevalence of obesity relative to those who didn't live near fast food. So, to recap, analytic cross-sectional studies start out by recruiting a sample of people. We don't know who in the sample has the exposure or outcome at the time of recruitment. We find this out in step 2 when we collect data on the exposure and outcome from each participant at just one point in time. Next, we calculate the prevalence of the outcome in the exposed and unexposed groups. Finally, we find out if there is a relationship between the exposure and outcome by calculating measures of association, which, for a cross-sectional study, are prevalence difference and prevalence ratio. The key points of this lecture were that cross-sectional studies can be descriptive or analytic. Cross-sectional studies collect data on exposure and outcome from each participant at just one point in time. There is a limitation because we don't know about temporality, that is, whether the exposure or outcome happened first. However, cross-sectional studies can be a good type of exploratory study since they're relatively inexpensive, quick, and can be generalizable. The only measure of frequency we can calculate from cross-sectional study data is prevalence. Consequently, the only measures of association that can be calculated are prevalence difference and prevalence ratio, both of which tell us about the relationship between the exposure and outcome. So that's it for cross-sectional studies. Your next and last lecture video for this week is on case control studies. Please let me know if you have any questions. Bye, everyone.